Hello guys, my name is Darsh and I will be solving the 2025 AMC10A problem 14 today. In the figure below, the outside square contains infinitely many squares, each of them with the same center and sides parallel to the outside square. The ratio of the side length of a square to the side length of the next inner square is k, where k is between 0 and 1. The spaces in between squares are alternately shaded, as shown in the figure, which is not necessarily drawn to scale. The area of the shaded portion of the figure is 64% of the area of the original square, and we're asked to find the ratio k. So when we're finding k, we think of infinite geometric sequences, as it's explicitly stated that there's infinite squares. But you may ask, how to apply this for squares? Well, it may seem complicated, but it's actually not that hard. Okay, so let's look at the picture. When you see the picture, without loss of generality, let's say the outside side length is 1. And you know the inside from then will be k squared, k to the k cubed, k fourth, k to the fifth, so on. Now, from here, you may ask, why do we have to label the outside side length 1? Well, since we're dealing with ratio problems, whether the outside side length is 1 or 2 or whatever, it doesn't matter. But because the ratio of 2 to 2k or 3 to 3k is still 1 to k. So this just makes calculation easier. Okay, so now we're done with analyzing the picture. Oh yeah, one more thing. When we're trying to find the shading area, we have to find this area, the next instance of it, so on. So when we're finding this, what we want to do is, we want to find the area of the outer square minus the area of the inner square to find the shaded area. Then the area of the outer square minus the inner square, so on. So let's apply that. We have 1 times 1 minus k times k. 1 times 1 minus k times k. Let me make it look better. Yeah, so we have 1 squared minus k squared. Next, we will have k to the third times k squared times k squared minus k cubed times k cubed. So the reason we do this is because the area of a square is s squared, and the s in this case is k squared and k cubed. So you have k squared minus k squared times k cubed minus k cubed, and so on. So this will continue infinitely, where it's like that. So in this case, we need to find, so recall that the area of an infinite geometric sequence is the first term, or a1, over 1 minus r, where r is the ratio. Remember to not mistake this for k, as the ratio in this case will be different, and it's not k. So in this case, we need to find how the next term relates to the previous term. So let's factor out our expression and expand on that idea. So we have 1 minus k squared plus 1 minus k squared times k to the fourth. Then we have 1 minus k squared times k to the eighth. So when you examine the sequence, this will be k to the times k to the fourth. Next one will be times k to the fourth, and so on. Now, from this you realize two things. Actually, three things. One is that everything can be factored using 1 minus k squared. The second thing is that from this we learned that the first term is 1 minus k squared. And the third thing is that we know the common ratio, which is k to the fourth. So since it's asking for 1 minus the common ratio, it's 1 minus k to the fourth. Now we have this expression for the sum of the infinite geometric sequence. From this, well, if we go up to the problem, we realize that it says the area of the shaded portion or the infinite summation, is equal to 64%. And if you simplify that, you will get 16 over 25. Now you have this. Since this is a one equation with one variable, you can easily solve it. So once we cross multiply, you get 16 minus 16k to the fourth is equal to 25 minus 25k squared, right? Now we want to move it to one side to express it as a trinomial quartic. So we will have minus 16k to the fourth plus 25k squared minus 9, I think is equal to 0. Okay, so now we have this. And from here, you may ask, how are we going to solve it if we have a k to the fourth and k to the second? Well, over here comes the part of logical thinking, where you need to realize that you can make the substitution of y is equal to k squared, or whatever other variable is equal to k squared, so that it turns this quartic into a very simple quadratic. 16y squared plus 25y minus 9 is equal to 0. So now you have this. And here it's very simple to just apply the formula of minus b plus or minus b squared minus 4ac over 2a. So this is a very important formula, which is called the quadratic formula. Now we just plug in the values of a, b, and c to solve for x. So now once we plug it in, we get negative 25 plus or minus 625 minus 4ac. So a times c is 16 times 9, or 160 minus 16, which is 144. And 144 times 4 is equal to, let me think. So it's equal to 400 plus, so 576 minus 576 over 2a. And 2a is equal to negative 32. Now we have this equation, so now it's just a home run. So we'll just quickly simplify everything, and we get 25 plus or minus 25 plus or minus, so 625 minus 576, it is equal to 49. Yeah, it's equal to 49. Yeah, it's equal to 49, root of 49, which is just 7, over negative 32. So from here we get the answer that we can either have negative 32 over negative 32, negative 32 over 32, or negative 18 over negative 32. Now, if we simplify this, so the thing is, over here you can't be stuck that you have two answers, because if you go up here, it explicitly says that k has to be less than 1, and negative 32 over negative 32 simplifies to 1. So this is not a choice, it's extraneous. It's an extraneous solution. So now only one other case is negative 18 over negative 32. Cross out the negative signs, evaluates to 18 over 32. You divide by 2 on both sides, you get 9 over 16. But this isn't the answer, because we wrote that y is equal to k squared. And this is y is equal to 9 over 16, and we're finding k. So we just resubstitute back k squared. So you get 9 over 16 is equal to k squared. And now you get k is equal to 3 over 4. So the answer is... So the answer is k is equal to 3 over 4. And if we go back up here, we see that the answer is D. So before leaving, if you like the video and my explanation, you can like and subscribe. And if you want any specific question in this particular range that you want me to solve with some explanation, you can comment it to this video or any other math related video on my channel. Thank you.